again, students. This is Miss Denton again. And in this video, we're going to be looking at G11 Part C. Now, this is a really important part. My students really struggle with Part C here. Part C says, the students will use angles, arcs, chords, tangents, and secants to find arc length and areas of sectors in a circle. Now, this is a doozy. I don't know what it is about this topic, but students really struggle. It's probably because we have to, again, know some formulas. So let's check it out here. I've written out the formulas we need to know here. This is a very important box. Now, the two formulas we're going to look at are pretty similar to one another. We've got arc length, which is equal to theta, which represents the central angle, divided by 360 times 2 pi r. Now, what is 2 pi r? Think about that for a second. 2 pi r, that's the circumference formula. All right, so to find arc length, we're using a portion of the circumference. I hope that makes sense. To find this little part, we need just a piece of the full circumference. The sector area formula is quite similar. We've got theta out of 360, so again, a portion of the full circle, times pi r squared. Now, what is pi r squared? That's the area formula for a circle. Okay, so in arc length, we've got a portion of the full circumference. In sector area, we've got a portion of the full area. Let's do a little practice here. Let's start with area. The question says, what is the area of the shaded sector of circle P? Okay, so first I need my sector area formula. Sector area is equal to the central angle, which is 130 degrees, out of 360 degrees, times pi r squared, the area formula for a circle. And here it's given to us that the radius is 5. So pi times 5 squared. Now I want to practice our answer in two ways. I want to practice finding the exact sector area and then the rounded sector area. So what I'm going to do the first time is I'm going to use my calculator for help, and I'm going to type in everything except pi. Okay, I just did that on my calculator, and I got 325 over 36. Now, since I did not type in pi, that means the pi is still there. Okay, so the sector area is equal to 325 over 36 pi centimeters squared, because I'm talking about the area of the shaded space. This is called the exact value. Okay, I'm going to do this again, and this time I am going to use the pi button. So instead of having an exact answer, I'm going to use these wiggly lines, which are an approximated value, because I'm going to end up rounding. Okay, I just did that on my calculator, 325 over 36 times pi, and I get 28.3616, and I'm sure that goes on and on and on and on. And still, that is centimeters squared, and that's the rounded value. Both are good answers. It really just depends on how the SOL asks you this question or what kind of answer choices they offer in the multiple choice. Make sure you read the question carefully if it's a fill in the blank, so you know which style of answer you're going to be submitting. Okay. All right, our next example, let me slide this up a little, better light. There we go. Our next example says, An architect used this diagram to design a curved balcony. How long is the railing for the balcony? There's that important question. Oops. How long is the railing? So in my picture, here's the railing, and I want to know how long it is. Well, in the drawing, you're trying to find the length of the arc. You're looking for arc length. So I'm going to use this formula. Arc length is the central angle out of 360 times the circumference formula 2 pi r. So I'm looking for the arc length. The central angle is 70 out of 360 times the circumference formula 2 times pi times the radius, and the radius is given to us as 40. Okay, excuse me. Okay, I'm going to make the exact value and rounded answer so that we have both of them. In order to do the exact value, I'm going to type everything except for the pi into my calculator. So I'll do the 70 over 360 times 2 times 40. When I do that, I get 140 out of 9. Now don't forget, the pi is still there, and we are measuring in linear measure, not squared measure, so just feet. This is our exact value. In order to get the rounded value, I need to type all of this into the calculator, including the pi now. So I'll have an approximated answer, a rounded value. So 140 over 9 times pi. And I get 48.8692 feet, not feet squared, just feet, because we're talking about the length of the railing. This is my rounded value. And again, if I was answering this on the SOL, I'd really have to read carefully so I know which answer they wanted me to submit. Really pay attention to those details. All right, one final practice here. It says, given the circumference of the circle C is 144 pi, what is the length of arc AMB? We're looking for arc A to M to B, and we're looking for the length. It tells us exactly what we want. So in our arc length formula, we've got arc degree out of 360 times 2 pi r, which is the circumference. Now look, right here, they've given you the circumference. It says the circumference of circle C is 144 pi. So the arc length is equal to the central angle out of 360 times the circumference. 2 pi r is the circumference. So I'm just going to pop that 144 pi right into the formula. That's the circumference. First, I'm going to get my exact value. Remember, I'm going to completely ignore the pi when I'm typing in my exact value. 120 out of 360 times 144, don't use the pi button, and you should get 48. So the arc length and exact value is 48 pi, whatever the units are, feet, yards, inches, centimeters, whatever. The rounded value will give us an approximate answer, 48 times pi. 48 times pi is about 150.796, and again, that value continues on and on and on forever. That's our rounded value. So Yep, more formulas to know, guys. Lots of formulas in this circle piece, okay? Also, you have to read very carefully when you're looking at area, sector, and arc length, because you have to know, are they asking for the exact answer or the rounded answer? If they're asking for the rounded answer, where do they want me to round to? I'm listing all the decimals that show up in my calculator, but if they want me to round to the 10th, then I'm going to have to be very careful that I actually round to the right position, especially if it's a fill-in-the-blank question. This concludes our study on circles. Thanks for watching and happy studying.